So let me focus on the verification of our UCS iSCSI boot, right? That's where we wanted to focus on earlier. Did our iSCSI boot succeed? And did the fiber channel boot succeed? So let's first check that on the CLI. So let's log into our Fabric Interconnect and see what it did. Oh, connect NXOS A. Show NPV status. I see that I have a VFC interface up and running. So that means that I have at least one virtual fiber channel interface running. So I have at least one guy up and running. Show NPV floggy table. I see that the server interface also performed a floggy and that the server interface is now pinned to an external interface. So the NPV side is working. If I check my MDS1, I see a floggy in vSAN 100 for what kind of port worldwide name? The one that has AA in it. You see that? That's what we configured right in our pool. It says AA here. Now it did not work, or did it work actually? Show zone set active. It did not work because I did not create a zone yet. So I did not create a zone yet for my fiber channel boot device. So let me do that first. Zone the disk that we want to use and zone the initiator. That is my UCS server. Activate it. And now I see that AA guy. So let's figure out the networking configuration. Let's go back to our UCS manager that we have right here. And let's check the KVM console of the server. And let me reboot the server. Actually, let's just use Control-Delete to reboot the server. Now let's see what this all configured on Fabric A. So I see that I have 5 virtual Ethernet devices. One of them is using the 2100 VLAN. Remember what the 2100 VLAN was? That is my FCOE VLAN. So that virtual Ethernet 8885, again, number just came up. And that says switchboard access VLAN 2100. So this is my FCOE question. That is currently down, yes, because I'm rebooting the server. That's why it's down. Now it's coming up again because now the FC boot driver is doing, and look what it did. Look what it sees here. It's seeing the Seagate disk. Let's look at the virtual Ethernet now. Now it's up and running because the server was rebooting. So on the server side, yes, on the server side it was down. This is a server interface, right? This directly maps into the PCI bus of the server. So let me do the whole walkthrough on the packet path, right? So we connect to our server 1 through a fax interface, right? That fax interface 1/1/1. This is set to switchboard mode VNTag. So I have a blade, blade number 1 is connected to Ethernet 1/1/1. I know that by physical design. then this is set to VN tag. So that means that it now creates those virtual Ethernet interfaces for each of its VNICs. Now, how can I see which server is bound to which virtual Ethernet interface? By looking at the description. It says here, this is server 1/1, so chassis 1, server 1, VHBA FC0. I'm connecting that in VLAN 2100, and I bind that to interface E111, channel 693. 693 meaning my VN tag. You see? This is bound to this interface. So here I can see, based on the description, first of all, that this vEthernet is going across this fax interface. The fax interface is using physical interface 1/5 on the fabric interconnect. So if we translate that to a short drawing, we have the FI. This is link 1/5 going down to the fax. Here it is 1/1/1. And that translates into the blade on virtual Ethernet 8885. That translates into FC0. That is how I run from all the way back from what I configure in the manager all the way up to a physical interface. So I just start with a show interface description. So I see exactly what these guys map to. You see, 3 NICs in server 1/1, a VHBA and 2 VNICs, and 2 VNICs in server 1/2. Show service profile. Where's that? That's in the normal thing, I think. Not in NX, all right. That is a nice command as well, yeah. So what I first want to do is match, not match, that's GNOS, include vETH. Where do I match my virtual Ethernet interfaces to certain VHBAs? And you see that this vEthernet interface also matches to a VFC interface. Remember, this is a fiber channel over Ethernet tunnel. So I terminate that here in a vEthernet interface, and on top of that there lies a VFC interface. So a lot of things to take care of. So to track down the path of VHBA FC0, we start at the VFC interface because that's really the FC0 interface. Show run interface VFC 693. This is binding to virtual Ethernet 8885. 8885, so you can see here, VFC 693 binds to virtual Ethernet 8885. Virtual Ethernet 8885 binds to interface E1/1/1 VN tag 693. So 1/1/1. 1/1/1 is pinned to Ethernet 1/5 on the fabric interconnect. So that is how you can track the whole path from fiber channel interface to transport interface, so VN tag interface. And here going from my fax interface all the way up to the fabric interconnect. And I start with a show interface description for that. Find the interface that you're looking for. So the channel 693, that should not match the VFC interface. That's, I think, a coincidental thing. Because if I check the others, oh, it actually could match with the interface number here. Yeah, that could match actually. Never saw that, I never noticed this before, by the way. So I see that there is also a special QoS policy here. You see? Traffic shaping on there, bandwidth percentages. So I can verify everything that I've done here. And of course, because we are booting from Fiber Channel, I see a flaggy on the uplink Fiber Channel switch. Based on the worldwide port name, that should match here with the server. FC boot, storage part. This worldwide port name of VHBAA, so 25B5AA0F. 25B5AA0F, that's the port worldwide name, right there. You see, so I see the flaggy happening. And therefore I see that in the show FCNS database as well. Same one, 25B5AA0F has an FCID, so now it can access a storage target. Did I zone that together? Well, I just did that 5 minutes ago. But zone this port wide name with the disk, and now we can access it. So what you saw earlier that I pointed you to, it saw the Seagate disk. That means that the Fiber Channel boot is working, because I see the disk being active. For minutes, I want to move on with the verification. So, like I said here, we verified our Fiber Channel boot. We see the flaggy, we see the FCNS entry, we saw the NPV characteristics, and we saw the zoning. Now let's move on to iSCSI boot. So if we take our iSCSI boot server, let's set up a KVM console and reboot the server. I'm going to close this one. So let's type in the Control-Alt-Delete here. There we go. Now let's check our iSCSI boot. There is an excellent command to verify iSCSI boot. So is my iSCSI boot working? In terms of networking, I just see a VLAN being forwarded, right? So it's just Ethernet traffic. I do not see any flaggy or anything. But where I do see a flaggy is on my MDS switch, right? If you do a show iSCSI session, that's going to mean that I have an active session right now. If you see nothing in the show iSCSI session, it means that there is no session. So that's my first trick that I'm going to do, show iSCSI session. Actually, if you do not see a session and you want to see what went wrong, there is an excellent troubleshooting tool on the CLI of the UCS. When I go out of my NXOS CLI and I connect to an CIMC server or to an adapter, not to the adapter. So if I connect to the adapter, so I want to log in to the Palo card itself. So chassis 1, server 1, card 1. Actually, it's not server 1. It's adapter chassis 1, server 2, adapter 1. and then I type connect, attach, MCP. So you have to know these commands. If you look up the white paper for iSCSI boot in UCS, it's going to show you these commands. So connect to the Palo card, type connect, type attach MCP, and what I can do now is some iSCSI verification commands, like iSCSI ping. Can I ping from this particular VNIC towards the iSCSI target? Can I ping it? Oh, it tried, and it even does a TCP ping, so it tries to ping that certain port. So it even tries to connect to that port. So that's successful. That's cool, right? That's the first cool thing. Then the next cool thing is the iSCSI get config. Run this command because what this will do is it will start establishing a session towards the MDS, and it's going to tell you exactly what kind of error do I have. Can't I log in? Is my authentication failed? Do I have a connectivity issue? Do I have an IQN issue? Anything that there is going wrong here, that's what I can check here. That's cool, right? So remember this, so I see exactly what is going wrong, what is my IP address, what is my IQN, what am I trying to access. So verify your configuration. Can I ping? So is my networking stuff correct? But there's also a very good white paper on this. So if you check iSCSI boot UCS white paper, so Cisco made just a white paper of this using iSCSI boot. What to pay attention to. So this is actually from NetApp, I think. And that should show you at some point. No, it doesn't. There is some kind of white paper about iSCSI boot. So I'm going to run you through it again. Let me go exit this out. How you get to this? From the UCS CLI, do a connect adapter to the exact network card on the server that you want to get to. Then I'm in the Palo card, then type connect, then type attach MCP, and then type iSCSI get config. And that's going to show me all those details. So these 4 commands are crucial for verification. This is going to show me, do I successfully log into the iSCSI boot? Then if everything is successful there, go into your MDS and type show iSCSI session. Show iSCSI session detail is even better. This is going to show me how many commands did I send or receive from that guy. Do I have a connection? Apparently I do. Although I only transmitted bytes, I did not receive bytes. Well, that's okay. Now what is doing this? So I show iSCSI virtual target. So there is a target being accessed. Do I see an initiator? Yes, I do see an initiator. It is using iSCSI 1/1. It is getting this particular port worldwide name, and by doing that, it also performs a flaggy. The iSCSI interface will do the flaggy with the port worldwide name of the particular initiator. Boot configuration example. This is exactly showing you what to do, and most of all, how to verify it. So again, back to our MDS. The initiator performs a flaggy on the MDS through the use of the iSCSI interface. That also means that my zoning will become active. So I see that this particular port worldwide name, that 7F6E02, 7F6002 is now an active host here. You see? Cool, right? And now I can check, is my, well, it's not booting because nothing is installed on that particular disk, but the session is up and running and everything is working. So that is iSCSI boot and Fiber Channel boot.